In this video, I'm going to show you how to plot standard curve using Excel. Okay, first you have to obtain the ELISA raw readings from the plot reader. Okay, there are three sets of data as present. You should use the last one. Okay, this is already calculated the difference between the measurement and the reference measurement. Okay, the first step, you should identify all the data. I have identified all the data sets here. Okay, then I'm going to type the owner of the data. Okay, team 1, team 2, team 3, team 4. And last group, team 5, performance standard. Okay. All right. So next step, I'm going to calculate the average of the duplicate readings. Okay, using the function average. Then you highlight the duplicate data. You press enter. Okay, so once it is done, you can highlight the data again. Then you can use the mouse to drag and autofill all the wells. Okay, and you can do the same thing for all the rest of the teams. Okay, all right. Okay, very quickly you can calculate all the average values. Okay, so I'm going to leave the sample from team 1 and team 4 alone first. I'm going to calculate the standard curve. Okay, sorry, there's one value missing. This is for the average. Okay, so team 5 performed the standard calculation, okay, and I'm going to key in the standard value. Okay, the top standard is 12 microgram per mil. Okay, the top standard 12. This, and since we performed the twofold zero dilution, the second well is half of the previous well. Okay, you can do this formation. Then you can similarly you can drag all the way. Okay, the last one is blank. Okay, which there was no sample added inside. Okay, so okay, so this is the blank value. I'm going to highlight in yellow. Okay, so next step, I'm going to copy the sample name again so that you can see very clearly. Okay, next step, I'm going to subtract this background value from all the readings. Okay, so this is very simple. Equal the wells, then minus this value. Okay, here there's a trick. You can use a $sign to fix the second well. Okay, all right, so that when you drag the wells, only the first parameter will change and the second parameter do not shift. Okay, so similarly, you can perform everything, perform the calculation for all the values. Okay, don't worry about the negative values. We will deal with it later. Okay, for the last one. Okay, same thing. All right. Okay, so I'm going to copy the standard curve value down so that we can perform the standard curve. Alright. Okay, so this is the concentration. This is going to be your X values, and this is the absorbance. It's going to be your Y values. Okay, so to plot a linear graph, you highlight these two columns. Okay, then you go to Insert, Scatter Plot. Okay, the first one. Okay, you can move the graph sides here. Alright, so next step, you click any of the button, any of the data point, okay, to highlight. Then you right click, add trend line. Right, so on the right hand panel there is a format trend line window come out. You choose the linear equation. Okay, then you scroll down, you choose display equation and display R² values on the chart. Okay, so there's another option, set the intercept as 0, 0 point. Okay, so usually this is not necessary. Alright, so you don't have to choose this one. Alright, so once this is done, you do not need this window anymore. Okay, close this window. Alright, so now we have a standard curve. So in this standard curve, you can change the, give it a chart title. So we got antigen X ELISA standard curve. Alright, okay, so for the X and the Y axis, you can also give it a title. Okay, you can go to add chart element. Okay, click and click vertical. Okay, then you can come back here to change the name. So for the name, for the X axis, the name should be antigen concentration, just concentration. Okay, and the concentration, the unit should be microgram per ml. Okay, for the y-axis, okay, you can simply write absorbance, right? Or it can be more specific. It's OD 450 minus the background OD 570 nanometers. Alright, so then you have a very nice standard curve. Alright, so you see the grid. If you don't like the grid, you can click the grid and delete. Okay, if you can also highlight the line and format the line. Okay, for example, I want it to be solid line. I want it to be a red. Solid line. Okay, the dash type, I want to be solid line. Alright, nice. Okay, so that's the plot is done. So for the y-axis, you can, there's too many 0, 0. Okay, what you can do is to reduce the number of significant values. Okay, reduce the number of decimal points. So highlight the y value. Okay, click this button to decrease the decimal points. So usually 2 decimal points should be more than enough. Okay, and you can do other kind of formatting as well. Alright, so but what is important is this equation. So let me copy this equation. Okay, you can use this equation to calculate the concentration of your antigen in your measurement. Okay, the other value that is significant is this R square value. Okay, so R square value tells you the quality of your ELISA standard. If the R square value is close to 1, which means you have done your experiment very well. Okay, you have performed your serial dilution very well. So all the points are very close to the straight line. Okay, on the other hand, if the R square value is very low, let's say 7, 6, even 5, then which means your standard curve is not well performed. Okay. So let's come back to the linear equation. Okay, so the linear equation, in this equation, y equals to 0.451x plus 0.0501. Okay, so the x value corresponding to the concentration and the y value corresponding to the absorbance. Okay, so in our sample, we have measured the absorbance, but we want to calculate the concentration. So you have to manipulate this equation like this. Okay, you have to solve the x equals to, okay, just solve this linear equation, equals to y minus 0.0501. Okay, put them in bracket. Okay, then divide by the slope 0.0451. Okay, so that's the equation. Okay, so next step, we're going to use this equation to calculate all the concentration. So again, I'm going to copy down the data here. Okay, just easy to see. All right, so the x value for this for team 1. Okay, team 1 is 4. Okay, so for team 1's data, okay, I'll just copy these values. All right, so for example, I can calculate the first value, negative control. Okay, so I will take this value, okay, equals to this value. This is our y value. Okay, and I follow the equation minus 0.0501. Okay, I put them in bracket. All right, then I divide 0.05. Sorry, divide by 0.0451. Okay. Alright, don't worry about the negative value. So once I have it, I can drag, okay, to the auto calculation. Alright, so same thing. Because this column has no value, so I just highlight these two at the same time. Then I do a drag to auto calculation. Alright. So the units should be microgram per mil. Okay, so now let's deal with negative values. Okay, because concentration is not possible to be negative. Okay, so these when the measurement is very close to the background, so sometimes there's some fluctuation to give you these negative values, but these negative values have no biological meanings. So we can manually correct this. Okay, we change the negative value, just push it to 0. Okay, just push all the negative to 0. Okay, manually correct them. Okay. All right. Okay. So you can see here team 4 and team 3 and team 4's data very different from team 1 and team 2. So it seems that these two wells, okay, these two teams made a mistake. All right, so let's focus on team 1's data. Okay, so you can see negative control. Okay, the reading is 0, and for sample A, you have these 12 microgram per ml reading. Sample B is 0. Sample C is also 0. Okay. However, if you check the original absorbance measured for sample A, B, and C, okay, A, B, C is the values. Okay, so if you look at this value, actually exceeded, okay, 0.62, okay, exceeded the top standard in the standard curve. All right, so or it is very close to the top standard. Okay, so therefore it is very possible that these values already exceeded the range of the standard curve. All right, so the readings measured here may not be reliable. All right, but luckily we also diluted the sample 10 times, okay, and perform the same measurement. Okay, so for these readings, we can multiply back the dilution factor. Okay, so this one we diluted 10 times, so we just multiply the dilution factor 10. Okay, so same treatment for this. Okay, so you can see after 10 times dilution, the final value measured is more than sample A, more than the value measured through undiluted. Okay, so which actually tells you for the undiluted sample, the reading is actually not accurate. Okay, so you have underestimated if you did not dilute your sample. All right, so therefore the final concentration of the antigens measured for sample ABC should be this. Okay, so let me copy the value here. All right, and sample value, I copy the value here as well. Okay, so again I reduce the number of significant points. Okay, so then I can plot a bar chart. Let's go insert and then bar chart. All right, so plot a bar chart. Okay, so similarly you can add y-axis and x-axis titer. So here the y-axis titer should be antigen X concentration, okay, and microgram per ml. Okay, so this is the end of the this demonstration calculation of standard curve using Excel. Okay, so in the same document I have step-by-step guide of this entire process. Okay, I also included 3 separate sheets of data. You can practice using this data. Thank you.